Surface integrals are a little more challenging, but if you look at it from a mathematical perspective, they're not too bad. And what you do is you have a function and you're integrating over the surface. Usually both of these are pretty well defined. Sometimes you might have to parameterize everything. You'll basically have r of u of v, and then you'll have functions of u of v in every direction. Oops. Oh. Sometimes you'll see it written like it's a double integral. And then you'll see a cross product. Where Ru and Rv are the partial derivatives of the r vector. So you'll basically be taking this partial r with respect to u, and then cross that with partial r with respect to v, and then you take the magnitude of that cross product. Sometimes you'll see it written in a really weird way, but it's basically ds is equal to the square root, and then you have like the Pythagorean theorem, but now you have sometimes you'll see it written like that, and it is equivalent to taking the determinant of that. I think the best way to actually learn how to do this is to actually do an example. So let's say we have our function f of x, y is x squared plus y squared, and it's over the surface S. Let's say S is part of the plane z is equal to 4 minus x minus y. And we're going to do between x and y, between 0 and 2. Not sure how to exactly write that, but when we parameterize the surface, we're going to have xx unit, yy unit, and then zz unit. But remember, z is 4 minus x minus y. So then let's compute the partial derivatives. This is x unit minus z unit, and then ry is y unit minus z unit. And then take the cross product, and then take the magnitude, but first just find the cross product, which will be a 3 by 3 determinant, and then plug in the vector 1, 0, negative 1, 0, 1, negative 1, and then decompose it all. and then take the determinants of these. This would be 0 times -1 minus when it's all said and done, we should end up with x unit plus y unit plus z unit. Because this becomes a positive, this becomes a positive, and then that's just a positive. So then take the magnitude of that. So that's just the square root of 1 squared plus 1 squared plus 1 squared, or the square root of 3. Pretty simple stuff. And then this D stands for domain. So we're integrating over the domain. So that's basically how it does that. This looks like the Jacobian, but it is not the Jacobian. It acts like it, but it is not. We are not really changing coordinates. So now when we write this integral, 0 to 2, 0 to 2, x squared plus y squared dx dy, it doesn't really matter all that much in what order you integrate it. So we can integrate with respect to y first. We could split these up, and then put the other integral on the outside. So this x squared will be x squared y from 0 to 2 plus y cubed over 3 from 0 to 2 which would be 2x plus, and then y cubed, 2 cubed would be 8 thirds, and then we're integrating that with respect to x. So 2x squared, 2x cubed divided by 3 plus 8x over 3. So 2 times 2 cubed, which would be 8, divided by 3 plus 8 times 2, or all times the square root of 3. And 16 plus 16 is 32. So our surface integral is 32 root 3 over 3. Thank you.